already know what are the basic trigonometric functions. We already know what are the derived trigonometric functions. That means you know the definition of these things. Sine definition you know it as opposite by hypotenuse. Cos definition you know it as adjacent by hypotenuse. Now there is something called as reciprocal relations, right? These all you should definitely know it, sir. Even if you know it once more. Reciprocal relations, that means one trigonometric function is nothing but the reciprocal of other. The reciprocal of sine is nothing but cosecant. That means, can I say that whenever in so many questions it will happen like this, where sine theta and cosecant theta are multiplied. Please do not write it as whenever sine theta and cosecant theta are multiplied. Don't write this cosecant as 1 by sine again and waste your time. You know that they are two reciprocal things. You take any number, suppose 5. Reciprocal of 5 is 1 by 5. Product of two reciprocals will always give me 1. It is not only true in terms of trigonometry, it is also true in terms of number system or algebra also, right? Product of two reciprocal variables, product of two reciprocal numbers will always give me 1. Suppose I have cos. The reciprocal of cos is secant. That means cos and secant are reciprocal. Product of cos and secant is nothing but 1. Similarly, tan and cot. Tan and cot. Tan theta reciprocal is cot theta. Tan theta into cot theta, it is 1. These are the three reciprocal relations whatever we have, right? These are the three reciprocal relations what we have. Now the other thing which you need to know is, right, the other thing which you need to know is, now before knowing these things, now see here, sir, I am sure that these are some of the very important values which you already know it, right? Suppose for example, these are some things which you need to know, sir. Sometimes it might help in our problems. Sine of a plus b, it is nothing but sine a cos b plus cos a sin b, right? Cos a sin b. Now we will see how to remember all these things after some time, but we will understand these things. Similarly, if it is sine of a minus b, it is sine a cos b minus cos a sin b. Suppose if it is cos of a plus b, right? If it is cos of a plus b, cos means it will give me cos itself in the starting. Cos a cos b, if it is plus here, if the angles are added, then it will be minus on the right hand side, minus sin a sin b. Similarly, the reverse of it is, if the angles are subtracted here, it is cos of a minus b, then you will get it as cos a cos b plus tan a, plus sin a sin b, right? Sin a sin b. These are some things which you need to know. And another thing, these are nothing but basic trigonometric functions, sine and cos. I have one more derived trigonometric functions, which is nothing but a tan. Tan of a plus b is nothing but tan a plus tan b. We don't actually need the proof of all these things. You should remember all these basic trigonometric identities, so that our problems will be very easy in simplifying, which will take so much of time without knowing these things. And you need not know everything which is required in a textbook, sir. Not all trigonometric identities is required. Only few are required for your better understanding. Suppose if two angles are subtracted, then here also it will be minus, here it will be plus. I think these are some things which you need to know, basic values, right? Basic things which you need to know. Now if I take it forward, now in all these values, suppose for example I put a value equal to b, right? I put a value equal to b. If a is equal to b, then this becomes sine a minus a 0. Sine 0 is 0, which you already know. We will come to that value anyway very soon, right? Now if I put a is equal to b, and if I add the values in my first equation, then this becomes sine of a plus a, right? Sine of a plus a, which is nothing but sine 2a. In the right hand side also it becomes sine a cos b. B is nothing but a. It is sine a cos a, it will become, right? It will become sine a cos a. Similarly, right hand side after that it becomes plus cos A sin A. Sin A cos A and cos A sin A, they both are same. That means can I say that sin A cos A is added 2 times, it is 2 sin A cos A, right? Sin 2A value is nothing but 2 sin A cos A. The same sin 2A in terms of tan, it can also be written as 2 tan A divided by 1 plus tan square A, right? 2 tan A divided by 1 plus tan square A. Similarly, if I take my second equation which I wrote it here, or second identity, cos of A plus B, put A and B both same. If I put A and B both same, can I say that this becomes cos of A plus A, which is cos 2A. Right hand side is cos A, B becomes A, it is cos square A, minus sin A, it is sin square A. Cos 2A is nothing but cos square A minus sin square A. I can further simplify it. If I express cos in terms of sin, I can further simplify it as 1 minus 2 sin square A. I can further simplify it as 2 cos square A minus 1. That means, please understand the intent of writing all these things in my first class itself. Can I say that in some of the examples, cos 2A should be written in terms of both cos and sin. I will make use of this identity. Only sin, I will make use of this identity. Only cos, I will make use of this identity. If I want to express in only tan, it is 1 minus tan square A divided by 1 plus tan square A, right? 1 minus tan square A divided by 1 plus tan square A. And the last equation, if I put A is equal to B, it is the tan of A plus A, it is the tan 2A, right? These are something which will simplify your problems when we start solving it, sir. I will tell you how to simplify it in a much more easiest way after we start problems. Tan A plus B also is equal to A. Tan A plus tan A is 2 tan A divided by, it is 1 minus tan A tan B, it is 1 minus tan A is tan square A. These are some of the basic identities which you should be knowing before we start solving problems. Idea clear, sir? My heading itself in today's class says that it is trigonometric basics. Next, let us move forward. Now see here, sir. See here, can I say that initially I took this right angle triangle. I took this right angle triangle initially. This will be my 90 degrees. This is my angle theta if I am viewing from here. Now, this is triangle ABC, for example. Opposite to angle theta is opposite side. Opposite to 90 degrees hypotenuse. Adjacent to angle theta is adjacent side, right? Now, we also wrote Pythagorean triplets. We also wrote Pythagoras theorem, right? Pythagoras theorem. Can I say that this particular Pythagoras theorem, whatever we wrote, this particular Pythagoras theorem, it is nothing but given by hypotenuse square is nothing but opposite square plus adjacent square, right? Hypotenuse square is nothing but opposite square plus adjacent square. Sir, why is that this is required? Why is that we wrote it once again, which we already learnt? Now see here, sir, this is where I will teach you something else. Listen carefully, sir. You already know all these things once again, but how you got that is something also which is important. Now, can I say that there are only 3 sides. One is hypotenuse, one is opposite, and the other is adjacent. Now, this is the Pythagoras triplets what I have, Pythagoras theorem what I have. I will divide right hand side and left hand side by one of the side called as hypotenuse square. If I divide everything by hypotenuse square, can I say that right hand side or left hand side is nothing but hypotenuse square plus divided by hypotenuse square is 1. Opposite by hypotenuse, which trigonometric function it is? Opposite by hypotenuse is sine, but I am squaring here. Opposite square by hypotenuse square is sine theta whole square or sine square theta. Adjacent by hypotenuse, it is nothing but cos, but I am squaring. It is cos theta whole square or cos square theta. My first trigonometric identity is Sin square theta plus cos square theta is nothing but 1. How you got it, sir? Very, very simple. You took that Pythagoras theorem, divided right hand side and left hand side by hypotenuse square. Now, if I take the same Pythagoras theorem once again, hypotenuse square is equal to opposite square plus adjacent square. Now, you already divided it by hypotenuse square. Ignore it. Divide with any other side. If I take opposite square, divide both sides by opposite square. If I divide both sides by opposite square, can I say that left hand side is nothing but opposite by hypotenuse is sine. Hypotenuse by opposite is cosecant. It is cosecant square theta. Opposite square by opposite square is 1. Adjacent square by opposite, adjacent by opposite, what it is? Opposite by adjacent is nothing but tan, adjacent by opposite is nothing but cot. 1 plus cot square theta is nothing but equal to cosecant square theta. This is purely obtained by dividing my Pythagoras theorem with opposite side on both sides, opposite square on both sides. And similarly, the same Pythagoras theorem, if I take hypotenuse square is nothing but opposite square plus adjacent square. You divided by hypotenuse square, you divided by opposite square. The other thing which is left out is adjacent. Why do you ignore that particular person or particular value? Finish off that also. Adjacent square, if I divide by both the sides, this will become hypotenuse square plus equal to opposite square plus adjacent square. Divide both sides by adjacent square. Hypotenuse by adjacent is nothing but reciprocal of cos, which is secant. Secant square theta is nothing but opposite by adjacent. It is tan. Tan square theta adjacent by adjacent square is 1. 1 plus tan square theta is nothing but secant square theta. You need not by heart these values. You can derive it whenever you require. But this is something which we kept on learning from so many years. If it is already there in your mind, it is superb, sir. You can keep it in your mind just like that, so that you don't need to derive it also whenever it is required. I believe it is clear. Very, very easy way of remembering the values. No need to struggle to remember all these values. Very, very easy way. Now listen carefully. Now this is something which you might know already. The very, very beautiful standard angles are 0, 30 degrees, 45 degrees, 60 degrees, 90 degrees. 0, 30, 45, 60 and 90. And I have only two basic trigonometric functions. One is sine, the other is cosine. I will also write another trigonometric function, which is the derived trigonometric functions tan. Sine of angle, cos of angle, tan of angle. Now, very easy to remember, sir. Don't by heart again all these values. If you want to by heart also, probably it would be there already in your mind, because this is something which we are learning from so many days. If you want to by heart also, it is not that greatly difficult to remember these values. Now, if I want to find a sine, write down 0, 1, 2, 3, 4. Write down 0, 1, 2, 3, 4 in this particular order. After writing 0, 1, 2, 3, 4, divide each and every value by 4. Divide everything by 4. After dividing everything by 4, find the square root of all these values. Right? Find the square root of all these values. If I find the square root, I will end up with getting all the values. Sine, first of all, 0 by 4 is 0. Square root of 0 is 0. Sine 0 is 0. 1 by 4 square root is 1 by 2. Sine 30 is 1 by 2. 2 by 4 is nothing but half. 1 by 2. What is the square root of 1 by 2? 1 by root 2. Right? Square root of 1 by 2 is 1 by root 2. Similarly, 60. It is root 3. Root 3 I cannot simplify further. It's a third. It's an irrational value. Root 4 is nothing but 2. Sine 60 is root 3 by 2. 4 by 4 is nothing but 1. square root of 1 is nothing but 1 itself. That means write down natural numbers, in fact write down whole numbers from 0 to 4 in the same order, divide everything by 4, find the square root. You will end up with the answer. Now once you get the values for sine of all these standard angles, cos is never a difficulty. Cos is nothing but reverse of sine. Come in the reverse direction. Sine cos 0 is 1. Cos 30 is nothing but root 3 by 2. Cos 45 is nothing but 1 by root 2. Cos 60 is nothing but 1 by 2. Cos 90 is nothing but 0. Right? Cos 90 is nothing but 0. Similarly, if I take it further, if I simplify further, tan is nothing but the derived trigonometric function, right? Tan is nothing but the derived trigonometric function. This tan is derived from sine and cos as sine divided by cos. So 0 divided by 1 is 0. 1 by 2 by root 3 by 2, 2 will cancel, it is 1 by root 3. 1 by root 2 by 1 by root 2, both are same values. When divided you will get it as 1. Root 3 by 2 by 1 by 2, it is root 3. 1 divided by 0. Whenever you have 0 in the denominator, it is nothing but infinity, or in some cases we will also tell it as it is not defined, right? It is not defined. Now let us understand this carefully, sir. It is infinity, or in some cases you can also tell it as not defined. Now suppose for example, think logically. Suppose for example, I take this sine 0 value, right? I take this sine 0 value. If I take sine 0, I got it as 0. Think logically, sir. Suppose if I put a right angled triangle, right? If I put a right angled triangle, again I am explaining you in detail for your better understanding. If I put a right angled triangle, this is 90 degrees, this is the theta, right? This angle is theta. This is opposite side, this is hypotenuse, this is adjacent side. Now think logically, sir. What is the meaning of sine 0? Sine 0 is nothing but this particular hypotenuse, whatever is present, this line should keep on falling like this, and the angle should become 0, right? This theta should keep, this line should keep coming like this, and it should overlap like this at some point of a time, right? It should overlap. That means the angle should become 0. That means, can I say that we know the definition of sine theta as opposite divided by hypotenuse, right? Opposite divided by hypotenuse. That means, can I say that this opposite side, this will keep falling like this, and this will come like this, and it will fall on the base or on the adjacent side. That means this value becomes 0. If this becomes 0, 0 by any value will always give me 0. That means sine 0 value is 0, right? Sine 0 value is 0. Similarly, can I say that tan which value it is, sir? Tan 90 we are talking about. Tan 90 we wrote it as infinity, right? We wrote this tan 90 as infinity. Suppose if I take a right angle triangle, same like that, if I understand it, this is opposite side, this is hypotenuse, this is adjacent side, right? This is adjacent side. Now this is nothing but 90, this is nothing but theta. That means this theta should become 90 degrees. 90 degrees is nothing but infinite value. So this value should become 90 like this. That means, can I say that this line will never end? It will keep on going up till infinity, right? It will keep on going up till infinity. That means tan theta is nothing but opposite divided by adjacent. Can I say that this opposite side is nothing but what I am writing here on the right hand side? That's both are same lines. It will keep tending to infinity. Opposite will tend to infinity. Infinity divided by any value, it will tend to infinity itself, right? It will tend to infinity. That means these are the ways you can actually visualize how these particular values are coming from the diagram, and then we will understand how those values, instead of knowing in depth, actually I just told you some of the examples to remember some of the values, but in simple language, what is required for our examination point of view, we will remember all those values. So these are some of the very, very important trigonometric what is the standard values which you need to know, and I am sure that most of the people who are watching these videos already know about these particular values. I hope the idea is clear, sir. This should be very, very clear for you. Standard angle trigonometric functions. What if it is not standard angle also? We will understand it in our problems. Let us not fight here in our regular basic understandings. We will see what can be done in our problems. Let us move forward and understand something else. Listen carefully, do not write anything. First listen carefully, sir. Now, there is something called as, in trigonometry, called as transformation identities. Very, very important, sir. Transformation identities. This might also help you in your problems in some cases. Let us not ignore even a part of something which will help us in our problem solving, right? Let us learn everything in detail in our first class. We will take it forward in our next class, right? Transformation identities. What is the meaning of this transformation? As the name itself suggests, it will help you to transfer from one parameter to other parameter. Sir, what is the meaning of this? There are two cases. I am first interested in transforming product. If two terms are multiplied, I want to transfer from product to some more difference. Please listen to this very, very carefully, sir. Beautiful way of learning. I want to transform product into some more difference. That means there are four things in this particular case. Suppose sin A and cos B. There are two different angles A and B. These two are represented with sin and cos in my first transformation, and I am multiplying. This is the product. It is sin A into cos B. Sin A cos B is my first transformation. Second one is cos A sin B is my second transformation, right? Cos A sin B is my second transformation. Next, both of them is cos. Cos A cos B is my third transformation. Both of them are sin. Sin A sin B is my fourth transformation. Listen carefully, sir. How to remember it so easily, so beautifully. Listen carefully. Sin A cos B, cos A sin B. Cos A cos B, sin A sin B. All the things on the left hand side are multiplied. I want to convert that product into some more difference of trigonometric identities or trigonometric functions. Listen carefully, sir. In every of these cases, I will write it as 1 by 2. In each case of 4 cases which I wrote it here, I will write it as 1 by 2. Now first listen, then you can write it. In everything I will write it as 1 by 2. Now what I will next write is, I will write sine, I will add the angles, right? I will write sine, I will add the angles. I will write sine, I will subtract the angles. Don't worry whether it is plus or minus here in the middle, we will see that later. Similarly, I will write sine, I will add the angles. Just hold on, I will tell you when to write sine, when not to write sine. I will write sine, I will subtract the angles. Similarly, third one, I will write cos, I will add the angles. I will write the same cos again, I will subtract the angles. And the last one is, I will write cos, I will add the angles. I will write the same cos again, I will subtract the angles, right? I will subtract the angles. Now listen to this carefully, sir. Can I say that first one is sine, second one is cos? If two trigonometric functions given on the left hand side are different, if two trigonometric functions given on the left hand side are different, right hand side you should express in terms of sine. One time add with the angles, other time subtract with the angles. Similarly, second, first one is cos, second is sine. Again two trigonometric functions are different. Whenever two trigonometric functions are different, express in terms of sine. Add the angles, subtract the angles. Third one, cos and cos. Both the trigonometric functions are same trigonometric function. Both are cos. Whenever both are cos, express in cos. one time add the angles, other time subtract the angles. Similarly, sine and sine. Sine and sine both are same trigonometric functions. If both are same, express in cos. One time add the angles, other time subtract the angles. In simple language, can I say that if they both are different, express in sine. If they both are same, express in cos. Add the angles and subtract the angles. Now listen carefully, sir. What values or what symbols or what signs should come in between here? Now let us take care of those particular things. Now can I say that? Please understand this, sir. Whenever you have cos, assume cos as positive, right? Especially in this case. In some other case also it valids well. Assume cos as positive. Whenever you have sine, assume sine as negative. If it is cos, assume it as positive. If it is sine, assume it as negative, right? So cos is positive, sine is negative. Now if I go with this convention of cos positive and sine negative, can I say that? Now observe carefully. This cos is closer to this equal sign, right? Or it is closer to the right hand side. Cos is closer to right hand side. If cos is closer to right hand side, cos is nothing but positive. Right hand side push positive, right? Whatever is closer to right hand side, put that sign in between. Similarly, second one, sine is closer to right hand side. If sine is closer to right hand side, put that sign on the right hand side. Sine is nothing but negative. Put it as negative. Similarly, observe this. Cos is positive. Cos is positive. Right hand side should become which one? It should become positive. Or can I also say that first term is also cos, which is positive. Second term is also cos, which is positive. Positive and positive, it should be more positive. So I am putting positive here. Similarly, last trigonometric function, it is right hand side. The one which is closer to equal sign is sine. Sine is nothing but negative. So put that negative sign. But please remember, sir, first term is also sine. Second term is also sine. Negative is, first is negative, second is negative. Negative and negative, it should become more negative. So I wrote one of the negative sign here, but I want it to be more negative. Write down another negative side outside. So it is minus half. Now this is one of the ways of remembering it, sir. I am making it very easy for you to remember. There is no particular rule that you should remember in this particular method itself. You remember which is the easiest method for you, but we will ultimately remember. One of the ways to remember is to take cos as positive and sine as negative. May not be cos is positive always and sine is negative. To remember these trigonometric identities, transformation identities, I created this way of remembrance. So for you to make it little easier. I hope it is easy. I hope it is clear, sir. I hope it is clear. Now see here. Suppose for example, now whatever we wrote it on this left hand, let us try, without seeing, let us try to derive it. Suppose for example, I want cos A cos B. Please tell me right now, sir. For everything it is half. Okay, let me write it as half. Now both are same trigonometric functions. If it is same, I will write cos on both the sides. First time I will add it, second time I will subtract the angles, right? Second time I will subtract the angles. I told you that whatever is closer to the right hand side or equal sign, that should come, that sign should come here. Cos is closer to the equal sign. Cos is positive. Put a plus here. Over. You need not by heart it. You can derive it whenever it is required. Suppose, tell me the answer for this. Cos A sin B. No need to by heart. It is half everywhere. It is half everywhere. If both are different trigonometric identities, express in terms of sign. So write down sin and sin. One of the times add the angles. Other times subtract the angles. Whatever is closer to equal sign, sign is closer to equal sign, sign is nothing but negative, put a negative sign over, sir. That is exactly what I told in the last 5 minutes for you. No need to remember everything or no need to by heart everything for that matter. I hope the idea is clear. Anurag, hold on, sir. Numerical values is nothing but your problems, which I will discuss after teaching you basics. Yes, basics will always be little, because it is defined in general. So when we take some numerical values, it will give life for that particular problem. That we will have it in the session, sir. And I am repeating for third time today. Today see the basics. First we will make the basics strong. I hope. Kindly comment whether the first case of transformation identities is clear for you. Tell me this one, sir. Suppose if it is sin A sin B. Again I will not by heart sin A sin B. I will write it as half. I will write it as half. If both are same trigonometric function, I will express in terms of cos. Write down cos and cos. Add the angles once. Subtract the angles another time. Now check it out. Now they are saying that sin is closer to equal sign. Sin is negative. Write down that negative. But first term is also sin, second term is also sin. Negative and negative should be more negative. I only wrote one of the negative. Write down another negative to make more negative. Simple. No, Pramod Hegde, see, you should do some jugaad to remember, sir. I am not teaching you the actual way here. I am not teaching you the concept here. I am teaching you a shortcut method to remember. Yes, you are absolutely right, Pramod. Sin is negative. This sign is also negative. Negative into negative is positive. Yes, I am not teaching you this way. I am teaching you that remember in this method saying that negative and negative will make more negative. So I should put two minus signs. That is how I am making you to remember these values. I hope it is clear, Pramod Hegde. So we should do some jugaads to remember these values. Ultimately, end of the day, we should remember some of the things which is extremely required for your exam preparation, and we should clear our examination. For that thing, we will go to any extent provided that is a valid extent.